Okay, so in this video, we're going to be talking about slope-intercept form. And typically when we are using slope-intercept form, it's because we want to graph a line, okay? And usually in Algebra 1, this is what you're going to be using most of the time when you are graphing a line. You know, you have things like point-slope form, you have standard form, but 99% of the time, you're going to be using slope-intercept form. So you want to make sure that you're proficient with it and that you understand the different parts of it. So I have it all labeled out here. It's y equals mx plus b, and you may or may not have known that. But the different parts of it are pretty simple. So you can see here, x and y, okay? Both of these arrows are going to x and y, and you can see that x and y is going to be any point on the line. So if I were to graph a line and I pick any point on that line, I can represent that with x and y, and that is two different parts of my equation there, right? And then if you look at m, I have the slope of a line. Now the slope of the line is going to be rise over run. Another way to think about it is y over x, or your vertical over your horizontal. And we'll talk about that later on in this video after I get through the different parts of slope-intercept form. Okay, so m is going to be the slope of the line. And b is the easy one. B is the y-intercept. So whatever that number is, that is going to be where it's crossing the y-axis, your y-intercept value. Okay, and so really you can think of it like this. Your b, your y-intercept, is always going to be written in the following format. It would be 0, comma b. Because remember, the y-intercept is where it's crossing the y-axis, and that means the x value will always be 0 there. So it's going to be 0, comma, whatever this b value is. Again, it's going to be a point on the line, right, where it's crossing the y-axis. And so what I want to do now is give you a quick demonstration of how this all looks. And so what I'm going to do here, I'm just going to go ahead and draw a coordinate grid, and I'm going to put a line on this coordinate grid. Now it doesn't have to be perfect, and it doesn't matter what direction this line is going in. It could have a positive slope or a negative slope, right? So this will be y, this will be x, and I'm actually not even going to put any tick marks on this coordinate grid because it doesn't matter for what we're about to do, okay? So let's go ahead and make the line a different color, and we will go ahead and use a positive slope here. That's fine for this example. And so let's do the easy part first. What is going to be your y-intercept value? Well, your y-intercept value is going to be right here, this point right here, where it's crossing the y, okay? And again, we can represent that with 0, comma b, okay? And so now we have to figure out what is our x and y value. Well, our x and y value, that is going to be any single point that you pick on this line. It doesn't matter. It could be any one of these points, right? It's infinite because this line is going to infinity on the positive end and negative infinity on the negative end. So it doesn't matter what point. It's just any x and y point. And then your slope is simply when you pick 2 points on the line. So for example, let's just assume we're going to use this point here and this point here, and you're just going to do rise over run. So starting at any point, it doesn't matter which one it is. I'll just start here. I'm going to do rise over run. And you can see what happens here. I actually draw in a triangle, right? So this part right here, the vertical part, is rise over run, the horizontal part, right? And so again, this whole thing is being represented by y equals mx plus b. That is slope-intercept form. Okay? So now we're going to talk about how do we graph when we have an equation in slope-intercept form. So these are going to be the next 3 examples that we do. So let's go ahead and take a look at the first one. So here is our first example, and I can clearly see that it is in slope-intercept form because this part right here is my m, this is my b, and then again, I have my x and my y, which is being represented by any point on that line, okay? So let's go ahead and graph it. So let's get rid of this stuff here. Let's put on our coordinate grid. And this is pretty straightforward. You just have to remember the steps in which you graph. So this will be y, this will be x. So what you want to do here is put on your y-intercept value first. So my y-intercept value is right here, it's 2. And remember, that is 0, comma 2, right? So if I go ahead and put that on, I start at the origin right here in the center. That's our origin, right? I'm going to do 0, comma 2. So 0 on the x and then up 2 on the y and make a point. That's your first step. So your first step, always put on the y-intercept value, okay? Next, you want to put on your slope. what is my slope? Well, slope is rise over run. And I can see that it's going to be this part right here, this 2. That is my slope. But we always want to write the slope as a fraction. And so in this case, it's not just 2, it's 2 over 1. And we want to write it as a fraction so I can see the different parts. This part is my run, this part is my rise. So when I graph it, it makes sense, right? So going back to the point you first made, your y-intercept value, you're now going to put on the slope, which is 2 over 1. So that means starting here, you're going to go up 2, 1, 2, and then to the right, positive 1. I'm going to the right because it's positive. So then to the right 1. And there's going to be my point. So that's fine. Now you can even go in reverse if you want. Starting at the y-intercept, instead of going up 2 to the right 1, you could go down 2, so down 2 to the left 1. And that will give you the opposite end of the line. Okay? So now I have 3 points. I can go ahead and connect them. So let's go ahead and make this line in a different color. So connecting these 3 points. And you want to make sure you put arrows on the end of your line, because if you don't, it's going to look like a line segment. This is not a line segment, right? This line is extending all the way to positive infinity, and it's also extending all the way to negative infinity. Okay? So that's important that you are putting arrows on the end of your line. And that's graph. That's totally done. So that is graphing in slope-intercept form. Let's try another problem here. So here's another problem. Now we're dealing with a fraction, but it's not a big deal because that's actually how we want the slope to be represented by. We want it to be represented by a fraction. So just labeling it may make it a little bit easier. This is m, this is b. And if you want, you can write your y-intercept as a point. It's 0, 5. Okay? And then your slope, again, is 2 over 5. So let's go ahead and put on our coordinate grid. Again, this does not have to be perfect. You're doing it by hand, right? So this is my y, this is my x. And so here I'm going to go up 5, right? I'm putting on that y-intercept first. Starting at the origin, you're going to go up 5. So 1, 2, 3, 4, 5, right? Make a point. My next step, I'm going to put on my slope. What is it? It's 2 over 5. Remember, rise over run. So that means starting at this point that I made, I'm going to go up 2, 1, 2, and then it's a positive 5 for my run, meaning I'm going to be going to the right. So 1, 2, 3, 4, and 5. And let's go ahead and make that point right here. And 2 points is sufficient. You really don't need 3 points. But if you wanted to get the opposite end of the line, again, just go down 2 and then to the left 5. Okay, but I'm going to stop right there. 2 points is totally fine. Let's go ahead and make it in a different color. And again, make sure you're putting arrows on the end. That's important because if you don't, right, it's going to look like a line segment. So let me give you an example of what you don't want to do, because I see this a lot. You don't just want to connect these points. Don't do this, okay? If you do that, that is a line segment, right? We're not talking about a line segment here. We're talking about an actual line. And it needs to be extending on both ends, going to positive infinity and negative infinity. So this right here, again, would be incorrect. Don't do it this way. Make sure you are extending it all the way and put arrows on the end. Okay, there it is. And again, this has a positive slope. You can see the direction of it. Okay, let's try one more problem. Okay, so this problem is a little bit different, all right? And you have to have knowledge of solving equations. And if you're doing slope-intercept form, you probably already have gone over that, or you should have, okay? But I do have videos on that, so make sure you check it out on solving equations, 1-step, 2-step, and multi-step, because you do have to know how to do that in order to do this problem here. So it's telling you to put the line in slope-intercept form and then graph, okay? Right now, this is in standard form. What is standard form? Standard form is when your variables are all on one side, and it can be represented by ax plus by equal to c, where a and b are going to be coefficients in front of your variables, and c is your constant, which you can see here. 3 over 2 is my coefficient in front of the x, -1/2 is my coefficient in front of y, and -2 is my constant. This is standard form. Now, technically, you can graph in standard form. You would find the intercepts. And again, I have a video on that as well, so make sure you check it out. But the problem is asking us to graph in slope-intercept form. So we're going to have to rearrange it, meaning I want this entire thing to say y equals. That's the goal. I want it to say y equals, meaning I have to isolate the y here, okay? So let's talk about how we're going to do that. Let's get rid of all this stuff here. How are we going to do that? Well, our first step, I want to get rid of this term right here. I'm going to move it over because remember the goal. The goal is to isolate y. This is our end goal right here. We want this thing all alone. So that means our first step, we have to get rid of this term here, 3 over 2x. Now, what is the opposite of addition? Because this is a positive, right? A positive 3 over 2x. Well, it's going to be subtraction. So in order to get rid of it, we are simply going to minus 3 over 2x on both sides. So right here, minus 3 over 2x. We're also going to do it right here. Minus 3 over 2x. Let's see what we get here. This whole thing cancels out. That's what we want. I'm going to bring down negative a half. And then we have y equal to, now this right here, these two terms are not like terms. We can't combine them. So we're just going to write it as is. But I am going to put the term with the variable at the beginning, not at the end. That way we're set up for slope-intercept form, which we know is y equals mx plus b, right? So I'm going to write it as negative 3 all over 2 and then x and then minus 2. Also, this is a good time to talk about this negative right here. This negative right here, you can put it out in front, you can put it on the numerator, you can put it on the denominator, but you cannot put it on both. Okay, so what do I mean by that? Well, what you don't want to do is this. Don't put the negative on the 3 and the 2 like this, because then what happens, you're changing the entire problem. It's now becoming a positive 3 over 2, not a negative. Okay? So typically, the default that I always use, I always put that negative, if it's out in front, on the numerator like I did here. So I'm putting negative 3 here. Okay? That's typically where I always put it. Technically, you could put it on the denominator. It's just not something I typically do. All right? So I put it on the numerator here. That's totally fine. Now, right here, I have to get rid of this negative a half. So it's negative a half times y. Or another way to look at it, it's going to be negative y all over 2. Okay? And so that's division. So how do I get rid of division? I multiply. Now, what am I trying to get rid of? I'm trying to get rid of 2 right here, but I also want to get rid of this negative. So I'm going to multiply both sides by not just 2, but a negative 2. Okay, so getting rid of this here, let's go ahead and do that. So I'm going to multiply this side by a negative 2. That gets rid of this fraction and the negative, right? I'm left with just y. Now be careful, you have to do it to all of your terms, meaning I have to multiply this term by negative 2 and also this term by negative 2, okay? So what happens here? Well, look, the 2's cancel. That's good. And then I have negative 3, but I still have a negative here. It's negative 3 times negative 1, which is positive 3. So we get y is equal to positive 3x, okay? And then negative 2 times negative 2, positive 4. Here it is. We're now in slope-intercept form. I can clearly see the different parts. I have my m, I have my b. I'm ready to go. So we're going to go ahead and box that in, and now we're going to graph it. All right, so let's make a quick coordinate grid and put this line on. Here is y, here is x. Okay, so our first step, the y-intercept value, which is 4. That means I start at the origin and go up 4. So 1, 2, 3, and 4 make a point. And now our slope is 3, but it's really 3 over 1. Right? So rise over run, meaning I'm going to go up 3. 1, 2, 3. And then to the right 1. Just like that. Okay? And again, if you want to go in reverse, you simply just go down 3 and then to the left 1. But I'm going to leave it like that. 2 points is fine. So let's go ahead and make this line in a different color. We'll make it in red. Again, making sure to extend all the way with arrows on both ends. So that's it. That is graphing in slope-intercept form, and that is essentially what slope-intercept form is. You want to make sure you are proficient in slope-intercept form because, again, in Algebra 1, it's typically how you're going to be graphing lines. You could technically graph in standard form. You could graph in point-slope form, but most of the time, it's going to be slope-intercept form. So again, make sure you are proficient with this method. So that's going to do it for this video. If you found it helpful and you gained something from it, make sure you give it a thumbs up. Also, make sure you subscribe so you get more math videos in the future, and I'll see you in the next one.